Okay, so we use the word Polaroid, but Polaroid is actually a trademark or a trade name created by Edwin Land back in the 1930s. And what was developed was it's a sheet of plastic basically that's embedded with tiny crystals of an iodine compound. So those tiny crystals on the plastic sheet, they're kind of arranged in a picket fence format. So if I take a sheet of plastic like that and I insert my iodine crystal compound, we get this kind of picket fence pattern on the sheet. Of course, that's enlarged from what it would really be. And some of the electric field waves get absorbed by the material, and others can pass through unhindered. So unpolarized light that passes through a Polaroid gets polarized in one direction. So if it passes through one Polaroid, okay, we got our light, passes through, then it is polarized in one direction, but it loses some of its intensity. And the reason for that is because some of the electromagnetic waves are they're absorbed. So what we find is that the intensity after it goes through the Polaroid is half the original intensity. So I2, intensity 2, equals 1/2 intensity 1. Now, if we look at a polarized light passing through a second Polaroid that's oriented at some angle, all right, then we find that, and let's draw it up first. Here's my first Polaroid, here's my second Polaroid. So we have our light waves coming in. That's my original intensity. Then we have a new intensity I2, and finally it passes through that Polaroid at an angle. All right, so what's happened is the second Polaroid here gets rotated. So if I put the iodine crystals on the first one in this direction, this one I'm going to slightly rotate it. So if they're not lined up, okay, more of that intensity is absorbed. So we know the relationship here is that I2 equals 1/2 I1. Now what happens with the value of I3? Well, the relationship that was discovered is that the intensity 3 after it goes to the second Polaroid is the second intensity I2 cos squared theta, all right, and that is the angle of rotation, angle between Polaroids. All right. And there is your formula, but let's clean this up a little bit because we want it in terms of the initial intensity. So I'm going to just bring that down here so that I3 is actually equal to, I know that I2 is equal to the original intensity, half the original intensity, so we can rewrite this as half I1 cos squared theta. So there we go. So there is your intensity after light passes through a second Polaroid. So if it passes through the first one, it's half. If it passes through a second one, we use this formula. So I have a quick example here. Finish up Polaroids. So two Polaroids are crossed with an angle of 50 degrees between their polarizing directions. What percentage of light is transmitted? So we are looking for I3, and it is 1/2 I1 cos squared theta. So we take a look at plugging this into the equation, and we find that we can just do the calculation. 1/2 I1. Just going to keep it in brackets. I'm going to change it to cos 50 squared just to remind you that you do the trig first. So we end up with 1/2 I1, and using a calculator, we get that this value to be 0.64 squared. So multiplying the 0.5 and squaring that value, we end up with 0.2, and we'll round it to 1. So therefore, the percentage of light is, convert that to a percentage, 21%. So it is 21% as bright as it was originally. All right, that ties up calculations with our Polaroids. Moving along to the next video then, we'll see you in a sec.